Okay, so last we left you, we were talking about T2 star decay. And we said that T2 star decay is decay in the XY plane. And furthermore, T2 star decay is actually caused by the inhomogeneities of the main magnetic field. So the main magnetic field will be, say, 3 Tesla, but it won't be perfectly 3 Tesla all throughout. So those areas that it's slightly higher or slightly lower will make the hydrogen ions in that part, the vectors go slower or faster, and hence the vectors go out of phase with one another. And it looked something like this, just to refresh your memory. But the thing about T2 star is that it's reversible. Okay? If we put a 180-degree pulse, so we flip these totally by 180 degrees, now the vectors that are going fast are going slow, and the ones that are going slow are going fast again, and instead of diverging, they converge again, and as they start converging, signal is regained. Right? So T2 star is reversible in some MRI pulse sequences, right? If you have this 180-degree pulse, you can reverse T2 star. Now, sometimes you don't want to reverse T2 star. Sometimes T2 star is what you're interested in, and functional MRI actually is interested in this T2 star because it takes advantage of the fact that deoxyhemoglobin causes inhomogeneities in certain areas of the brain, and it's by taking advantage of these inhomogeneities that are caused by changes in blood flow that we get our signal, our functional, our bold blood oxygen level dependent signal. So that was T2 star. Now there's another type of transverse relaxation that is not reversible, and that is T2. Now every tissue has its own T2, and the T2 is dependent on, well, it's dependent on several things, but one is the interaction between the protons themselves. Okay, and that is not reversible because it happens in a random way, and not in a predictable way. So if we move the T2 down from infinity to a level that to a small number, say 4 seconds, 4.7 seconds, we can rerun this experiment. If you notice, T1 is still infinite. And now we still have T2 star. We can't get rid of T2 star. But okay, let's say 4 seconds. We've changed the time for T2 from infinite to 4 seconds. And we put our 90-degree pulse there. And if you can see, well, it's not just the decay because of the inhomogeneities. We now have some other processes going on, which, as I said, part of it is the interaction between the protons in the tissue causing this decay. Okay, and in this case we can't actually recover it, so let's put this to 20 seconds. If we put a 90-degree pulse there, we have the T2 star going on. We can actually recover the T2 star. So it's going up again, right? But it will never go up fully because you still have the T2. Okay, so that is T2 and the T2 star. And the last relaxation time that we need to talk about is T1, which we'll do in the next video. And I think T1 is actually relatively straightforward, so I hope you'll get it quite quickly.